Dear viewers, welcome to another video on how to use graphical representations in Minitab. In this video, we are going to understand how to use the graphical tool called parallel coordinate plots. Let's understand this. As I was explaining, we are going to see in this video how we are going to use parallel coordinate plots to graphically represent how does multiple variables of same sample under discussion or same item under discussion changes between different set of data points. So if we read the definition of parallel coordinate plots, the parallel coordinate plots is a visual is used to visually compare the series or group of series on parallel coordinates for multiple variables. So that's what this graph is all about. So this is a new graph which is available in Minitab version 21. The previous versions of Minitab do not have this graph. So to make this to make us understand how does this graph work, I have three different types of data. The first set of data is there are 5 different team members who are working in a contact center. Their number of calls handled for the week, total sales that they are able to make for the week in terms of dollars, their call monitoring score accuracy, the average accuracy, and their average call handling time. So this is the information that I have. This is one set of data. Another set of data that I have is for 3 different batsmen during World Cup 2023, the number of runs they have scored for 3 different batsmen, and similarly the strike rate for those batsmen for World Cup. So here I have taken Rohit Sharma, Virat Kohli, and the New Zealand batsman Ruchit Ravindra. And since Ruchit Ravindra has played only till semi-finals, so I have not taken finals data. So this is from their group matches till semi-finals. So that data is available here. And the third set of data that I have is for one single team member, what are the number of calls he has handled for a given set of days. This is for 2 weeks. And what is the total sale that he made on each day, the call monitoring score for every given day, and his average handling time for that particular day. So I have these kinds of data. So using this, we will understand how this parallel coordinate plots work. So I click on graph, and once I click on graph, I am going to select parallel coordinates plot. And when I select this, I'll be able to select my variables. So display individual series. So in this drop down, I can display groups, but in this case, I'm not going to display groups. I'm going to display individual series. And in this individual series, I am going to display calls handled by my team member. That is total number of calls, total sales he made for that week, average accuracy for his call monitoring scores, and average call duration, that is average handling time. And here I can select standard units, original data, percentage range. So standard units will create your scale as per the data that we are looking for. So let me select standard units here, and let me click on OK. So here we are not going to do any grouping. So I am not going to select grouping. And label, if we want to label, then team member name will be the label. So I'm going to select team member name as my label data. So I select team member name, and then I click OK. And when I click OK, I get this kind of a graph. So how do we interpret this graph? Let's see. So this graph is drawn on standard units. So what do I mean by standard units? Calls are measured in terms of number of calls, and that data in the given data. So we are talking about team member 1. Team member 1 is blue colored graph. Team member 2 is red colored graph. Team member 3 is green colored graph. Team member 4 is the purple colored graph, and team member 5 is again kind of black colored graph. Now if you see this particular data, team member 1, if you keep your mouse pointer, you will see in call handling that the performance of the team member is exceptionally well, whereas when it comes to total sale, he is not the top performer, and when it comes to accuracy, he is again second best, and when it comes to average handling time, he is the best, because average handling time is lower the better. So I understand this particular performer on 4 parameters: calls handled, total sales, and accuracy, and average handling time. And similarly, if I try to understand how is my second team member is performing, so second team member is doing well or doing kind of average when it comes to call handling and total sale, but in accuracy is doing well, but his call duration is very high. And so team member 1 we'll be able to see. So this is how we can understand this parallel coordinate plots comparing 5 team members on 4 parameters in a same graph. So there are 5 team members and 4 parameters on the same graph. So this is how the parallel coordinate plots work. But we will use this for a different context also, depending upon how creative we are and how well we are able to use any particular graphical representation. We can do it in different ways. So the second scenario is, I have taken Rohit Sharma, Virat Kohli and Rachit Ravindra's scores they have done during the World Cup, number of runs, and I have also taken their strike rate. Let's draw a graph using that. So I click on graph, I click on parallel coordinates plot. This time I am selecting the runs scored by Rohit Sharma, Virat Kohli and Rachit Ravindra, and then I click OK. So I am keeping standard units only here, and then I am clicking on OK. Okay, I think here I need to remove the label option and I can click OK. Yes. Now if you see this graph, you can see standard units depending upon how much runs they have scored. You got Rohit Sharma's value, you got Virat Kohli's value, and you have Rachit Ravindra's value. This is kind of misleading if you want to compare the amount of variability in their performance. So what we are going to do is, we are going to change from standard units to original data. And then we are going to click OK. Now if you see, the scales are rearranged with the common numbers. So 0 to 125 for all the 3 players. And now if you see, the amount of variability, it's almost spread across. So in terms of runs, there is a lot of variability, but Virat Kohli have more runs on the higher side of 75. There is a lot of data points for Virat Kohli on the higher side of 75 and very little or maybe few data points on the lower side of 75. But when it comes to Rohit Sharma as well as Rachit Ravindra, the runs are scattered all over the place, from all the way from 7 runs or 9 runs, it's all the way up to 125 for Rachit Ravindra, and from 0 to 125 for Rohit Sharma. Whereas for Virat Kohli, there are more data points on the higher side of 75 and very few 4 data points on the lower side. So this is how you can understand the variability on a standard unit. Now we will see the same variability using this graph for strike rates, like how we have seen for run. Let's see it for strike rate. So I click on Control E. Instead of having number of runs scored in my parameter, I am going to select strike rate of Rohit Sharma, strike rate of Virat Kohli, and strike rate of Rachit Ravindra. I select this and then I click OK. So I'm going to still keep it on original data. The reason is, I wanted to compare it on the common scale. Then only I'll be able to get a better picture of the variability in all the 3 players. I click on OK. And now if you see here, it's the strike rate is anywhere between 0 to 200. The reason is, there are certain matches where Rohit Sharma had strike rate all the way up to 200, and there are certain matches where his strike rate was 0. So this overall range of all the 3 batsmen put together decides the scale of this graph. And in this graph, it's again very evident, except for 2 matches, Virat Kohli's strike rate is more or less in the range of 73 to 106. So it's very closely packed. Whereas if you see for Rohit Sharma, it is very widely packed. And if you see for Rachit Ravindra, relatively okay. It is between 50 to somewhere around 130. But in terms of strike rate, the more, what I should say, consistent performance with very less variability comes from Virat Kohli. Maybe that's why we know why Virat Kohli is considered as a more consistent batsman, because both in terms of number of runs as well as in terms of strike rate, his variability is very less. Maybe there are matches where Sharma's strike rate is much better than Virat Kohli, but in terms of variability, Virat Kohli's variability is very less. That's why the data points are packed very close. This is one way of using this graph. Now I'll come to the third scenario, where you see here, this is for one single team member, number of calls handled, total sales for the day, call monitoring score for the day, and average call duration for the day. So this is for one single resource, and we are going to see on these 4 parameters, where is the resource having more variability and where is the resource having less variability. So here I again click on graph, I click on parallel coordinate plots. This time I'm going to select calls handled. Since I have 2 columns with calls handled, so this is referred as calls handled _1. So I'm going to select total sales, and I'm going to select accuracy, that is call monitoring score for the day, and average call handling time for the day. So here I'm going to use again standard units, not original data. The reason why I'm going to use standard units is the unit for each of this is going to be different. Calls handled, total sale, each of this, the units are different. I cannot keep it in original data. I have to keep it in standard units. Then only you will have a scale for each of this variable created as per the range of that particular variable. So I keep standard units and then I click OK. And when I do that, here you will see the call scores data is from anywhere from 9 to 15. The total sales data is based on the range, and similarly accuracy data is also based on the range, and that is average call handling time, that is also based on that range. And if you see here, number of calls taken, there is a lot of variability for the same resource, whereas when it comes to accuracy, that is call monitoring scores and also call duration, the variability is relatively less. So where there is high variability, where there is less variability for any given day can also be understood by this particular graph. So this parallel coordinate plots gives us a very good graphical representation in terms of comparing the performance on multiple parameters for the same resource or the same sample. And also if you want to compare multiple resources or sample on multiple parameters, then also we can do that. We have seen all the examples here. We have seen an example of multiple parameter of a same resource as our third example, and we have also compared same parameter for different resources like number of runs scored or strike rate of 3 different batsmen. And the last one is for 5 different team members, 4 different parameters, how it need to be compared. We have seen all those graphs in this video. I hope this is a very good addition to the list of graphical representations that we already have in Minitab, and using this you will be able to have a better representation of the data that we want to represent and communicate the information that we want to communicate through our data analysis. For more videos on how to use tools, techniques and graphical representations of Minitab, you can subscribe to our channel. Hope this video was useful and you will be using this video in your upcoming project presentations. Thank you for your time.